Welcome everyone, super glad to have you here. It's good to see some new faces and returning faces. We have a very special guest this time, Dr. Miriam Friedel, all the way from Charlottesville, Virginia, Skafos.ai, here to give us the lowdown on machine learning on iOS devices. So give her a warm welcome and let's take it from here.
I go to UVA, so I'm a little upset about that with some people. So thank you guys all so much for coming. I hope my speaking style's pretty informal, and I want you to ask a lot of questions. Hopefully this will be more of a conversation than just me talking at you. I'll give you a little bit of background about our company before I jump in. So as Patrick said, we are based in Charlottesville, Virginia. I'm UVA. Who recently won the national championship for basketball. We originally were a Metis machine, but we originally rebranded to be Skafos. And what we have built is a platform, toolkit, a way to deliver machine learning into iOS devices, into your apps that you can build, right? How you can use machine learning in those apps. We originally started building a platform that covered more of the machine learning lifecycle, like how do you actually build the model, sort of the tool for data scientists and machine learning engineers, but now we're really focused on mobile. So we'll talk a little bit about that process. I sort of came into machine learning by accident. I have a PhD in physics, and I worked in consulting for a while, worked in an imaging lab, and then sort of came into data science after that. So a bit of a mutt, I guess, sort of my professional background. I know very little about mobile engineering and Swift and all of that. It's all new to me, so I'm excited to learn from you guys as well. So this is what I'm going to talk about. We're going to talk about machine learning. What are some special things that you care about doing it on mobile? I'm going to give you a demo of our platform, which you're all able to log in and try out for free. So if there's time to want to do that, we can go ahead and do that, and then have some Q&A and discussion. So, I want to sort of take a poll. How many of you guys write apps or app developers? Cool. So how many of you do that as like your primary day job person? Okay, most of you, right? Are there any data scientists in there?
Social scientist.
Social scientists, you're
I work with data and media.
Okay.
Data visualization is more.
Okay, so we get your hands dirty in data, and I think you said at one point you do web apps, maybe? Yeah, okay, cool. So everyone's pretty technical. Okay, so I'm gonna talk more, I'm gonna focus sort of on machine learning and then what do we do with it. Machine learning is a big topic, so we're not gonna even cover anywhere close to all of it. So why machine learning, right? Why do we even care about this, and why do we care about putting it in mobile devices? And the reason is because there is a certain class of really relevant and useful problems that you either can't solve them or you can't solve them in a meaningful way if you don't use machine learning, right? So it can really advance our capabilities and solve things that previously we weren't able to solve. So let's talk about some examples of this to ground ourselves, right? Everyone has probably shopped on Amazon and you buy things and then you get recommendations for more things, and you buy more things and you continue your recommendations. Also on the left, we have a similar sort of thing from Starbucks, right? I ordered my drink, I want to go pick it up, and Starbucks is like, hey, maybe you'd like these other things. So this is a class of machine learning problems called a recommendation engine. And the reason it works so well is because Amazon and Starbucks and whomever takes my data, right, the data I've generated, and it combines it with all of the other data from millions and millions of other people, and it builds this model. And it combines both of these pieces of data in order to make recommendations. And if you're like me and have children, sometimes your Amazon recommendations get a little wacky because there's your stuff and your kids' stuff. Or like Netflix, right? And Netflix is like, you might like this. And I'm like, exactly, I would not like that Netflix, thank you, right? So this is a recommendation engine. This is the type of machine learning. Okay? Wayfair, right? Augmented reality, right? You're like, hey, I like that chair, what would it look like in my home, right? That's an example of machine learning. Another Wayfair app, which I really love, is using a type of model called image similarity. I'm like, hey, I love this chair. Take a picture of it, and it says, here are the most similar chairs in our inventory. Here's a link, would you like to buy them, right? So that's another type of machine learning. and then Snapchat filters, everyone's probably really familiar with this. These are multiple different types of machine learning models, right? First you have to detect, is it a face or is it not a face? Then you have to detect, all of those points, these are called facial landmarks, right? And then you have to figure out sort of some probabilistic modeling of like, well, it's most likely this is her forehead, this is where she put the ears, right? So all of this is machine learning. And these are all kind of fun and cool and useful, and so now that we have more and more capabilities to build these models, we're going to be able to put, solve a broader class of problems with them. So, what is machine learning, right? I like to start with the technical definition in some sense because it's actually usually not that useful, and then we can sort of break it down to something that's more useful. So, the study of algorithms and statistical models that enable computers to form inference on new data without explicit instruction. And that's the part that I think tends to get people without explicit, because you actually kind of are instructing the computer, so we'll break that down a little bit. But it's basically you have data, right? If you do data visualization, right, you're used to like manipulating a lot of data, and that's always the hardest part. You want to find some patterns in this data, you build a model with it, and then you use that model to make decisions, right? Amazon's making a decision of what content to put in front of you. Interestingly enough, that's a problem where there's not, it's called unsupervised learning because there's not a right answer, right? Have you guys heard the term supervised versus unsupervised learning, right? So unsupervised is like, well, I'm going to suggest these 3 things, and if you buy one, that's great, but you could have suggested 3 totally different things, and you would have bought one, right? And so it's not which is the right answer, right? It's not, you don't know. Yeah, so let's use an example to talk about sort of that technical definition and make it more accessible. But let me pause. Do you guys have any questions so far based on what you said? No? Okay. So this is why I got excited when you brought your talk. We're going to talk a lot about that. So this is an example of supervised learning where I know the answer, right? So I'm going to build a really simple app, and I'm going to show you an example of such app that identifies cats and dogs, right? So I take a picture of something and it's going to tell me is it a cat or is it a dog? So the way I build this model is I have all of my input images. And I have, maybe I construct some metadata, right? Here's image number 1. It is a cat. Here's the link to the image. Here's image number 2. It is a dog. Here's the link to the image, right? And so here's all of my data. And I use this, I probably use some Python code. Maybe I use Turing Create, which is a particular type of library. Maybe I use a Jupyter Notebook. Maybe I'm on Google Colab, whatever, right? There's a bazillion different tools you could use. And you come up with this image classification model, right? This is the thing that comes out of it. And then the inference on new data without explicit instruction part, that part is I take a new image, right? So I take a picture of your dog. I forget his name on it. Sam, thank you. Yeah, so I take a picture of Sam, and this model has never seen Sam before, and it tells me, okay, Sam's dog with some probability, right? So that's why without instruction, right? It's never seen a picture of him before, and now we can identify that he's a dog. So this is the process, and this is supervised learning, right? When you're building this, we know that he's a dog, right? We know that, when we're building this, we know what the right answer is. Okay, so I want to talk a little bit about the process of doing this, just to ground us. Like, I'll give you the punchline first. The punchline is everyone focuses over here, but this is the part, this is really where the magic happens when you take a model and get it into a product and someone's using it. Like, do any of you work with data scientists in your organization? You do a little bit. And are they usually responsible for delivering things into products? How does that work usually?
Well, we're still in the process of figuring out how to use, we have lots of data.
Yeah,
We're figuring out how to use it right now.
Yeah.
So that's still to be determined.
To be determined, yeah. And that's a great lead into my next point, right? Is like the data gathering, right? Like, what is all this data I have? What can I do with it? I have all of these different databases, and how do I combine them, right? What is the primary key to map this database to the other database, right? So I have all this data and I can handle it, then I have to clean it, right? Oh, this column, which somebody said is useful, is 90% empty. Should I use it? Should I not use it? Do I transform to something else? I have all these pictures of dogs and cats, but as it turns out, my algorithm needs them to be in a specific size, right? You've run into that problem last, right? But maybe the grayscale is wrong, the color scale is wrong, right? So you have to clean your data. Then you do the model training bit. So we're very lucky because now we live in a time where there's tons of different types of frameworks, right? There's TensorFlow and PyTorch and all of these different, mostly Python, but other languages too, based frameworks where you can write a line or two of code, you feed it your data, and you have a model, right? But in order to get the model right, you have to test it, right? And this is an iterative process. And then finally, right, at the end, you get this object, you get this image classification model or an object detection model or whatever it is, and then you have to take it and you have to do something with it, right? You have to get to this part where you're constantly feeding it new data and you have to integrate it into a product. And that seems to be a real challenge for a lot of different companies that I work with. Is they will often like silo their data scientists over here, right? And the people tasked with building products are over here, and there's not a lot of collaboration. So one reason I'm really excited to be here is that you guys build things, right? You're interested in building things, and you want to put machine learning into those things, right? And so I hope I'll show you how our framework can help you do this, but also, having an understanding of this process, you can know when to, collaborate with the data scientist, when to say, okay, I've got this app that has this model in it, but it needs some updating, and how you guys can sort of work together, yet also asynchronously, because the processes don't happen with the same pacing or timing. Okay. So machine learning on mobile. Why are we excited about this? So I'm asking about you guys are excited about it, but I'll tell you why I'm excited about it. So the founder of our company, Michael Fisher, previously founded a company called Willow Tree Apps. I don't know if any of you guys have heard of Willow Tree, right? So he's very, he has a lot of connections in this space, and so we're lucky to have gotten a lot of feedback from mobile developers who are really excited to use machine learning, but they're like, I tried to start doing this, and then 8 hours later I've been reading about like TensorFlow documentation and neural networks, and I'm completely confused, and I don't know, like I want to use this, but I don't know where to begin, right? And so just like, when the App Store first came out, apps were like these fun things, right? And now they're completely integral to everyone's business, right? Like, you have your Bank of America app, your Citibank, like everyone has an app because they're so important, like they're fun, but they're also so important to drive your business. And so we believe that now, with all of these tools and frameworks for machine learning, there's going to be, like now, machine learning in your app is going to be core to the business. Plus, now that we have so much more, this phone has so much more compute power than the phone 10 years ago, we start to have the ability to run these ML models on phones. So we really believe it can change what's possible, and that's why we're excited about it. But what makes you guys excited about using machine learning?
I think the big thing, at least on the iOS, is that you can do the inference, or you can make decisions using the model on the phone without sending someone's data to the cloud, so there's more privacy there. And it's a faster response, and it's like can work offline. All those things I think are a big plus.
I think the interface too, rather than having your hands on it, talking to it, for instance, just all those types of things that will assist interface.
And security is doing it on the device as opposed to in the cloud is a big thing, but also just the ability to use it in your apps is super useful. It's been a core part of iOS since like 2010, 2012 or something like that. But and Apple's provided some books to look into that recently, but having it in your app is a whole different thing.
He's whining because he sees your tools.
Oh yeah. I can't give you those. I know that's why I used to write my demo. Okay, so there's some challenges, right, to doing this. There's some challenges generally delivering ML, right? You have these organizational technical challenges, right? But there's some specific challenges in the mobile space that are not really well solved, I think. So some of them, the model size and resources used, right? You guys as app developers are familiar, right? Like if your app runs so hot, your phone shuts down, no one's gonna use it. Or if it uses too much memory, like in some of these core ML models. So core ML is, Apple's sort of the core ML objects. I don't know if I would hesitate to call it a machine learning framework because it's not as robust as some of say TensorFlow or PyTorch or whatever, all of which you can convert to core ML, but it's the easiest way, I think, to interact with these ML models in your Swift code, right? Like that's what what Apple is pushing. And core ML models can be big, right? Like big, right? This is the difference between being on device versus someplace else, right? Having something that's 100 or 200 megabytes in AWS is like nothing, right? It's like laughable. Nobody cares. It's so small. But you put it on your phone, and then it makes a much bigger difference, right?
The connectivity too.
Yeah, the connectivity. Yeah, like if you even just pushing the model down to your phone, right, or whatever. The size of the resources is something you have to think about. Like we're very lucky that if we need a GPU, we can just open Google Colab in our browser and we have access to a GPU. Like Google just gives us that for free, right? So we have all this compute and all this storage, but you have to think about it differently on the phone. The other thing, which is challenging from a data science standpoint, which is not well solved at all, and it's something that we're trying to do later on this year, our product is typically when you build these machine learning models, so when I build the image classifier model, I'm not going to build it on the phone. Does that make sense? Like I do the training, I have the data in the cloud, right, and I generate this object, and then I need to get it to my phone somehow. And depending what framework I use, I have to go through a conversion process. And when I go through even if I don't go through the conversion process, the way that the model, when I validate the model sort of in the cloud or Colab or whatever, it might give me different results than when I'm on the phone. And for some things, it doesn't matter, right? If I'm 99% certain you're a dog versus 99.9% certain, right? Like that level of accuracy is fine. But, if I go suddenly from 99% to 95% for something where you really need a high level of accuracy, that can matter, right? So this sort of this pre and post conversion process can be a big challenge. And then one thing that you guys have been talking about is, does the model live on my phone, right? We're training the model on the phone. Previously, or not previously, even now, like a lot of models live in the cloud, right? And you hit them via an API, and you have really good connectivity, and latency isn't a problem. You can just, you can hit it, but there's questions of privacy. What if I don't have internet connectivity, right? There's a lot of good reasons to have the model live on your phone. And so this isn't necessarily, everything that's in the cloud.
So reasoning, if I create a TensorFlow model and I convert that to core model, there's potentially some accuracy loss.
There could be, yeah.
Okay, cool.
Yeah.
So you want to make sure you're testing it.
You want to try and test that, and that's not solved. We have a customer of ours that's like, I have no idea what my model's doing on the phone. Can you tell me? My data scientists, they build it, right? They build it. It's great, and we transfer the phone, and I think it's working okay, but I don't actually have a mathematical thing for that.
So if we want our model to learn from the user, these models are often hundreds of megabytes large.
Yes.
So if we ship it with the app, our app model is real. So would it have to be modified to learn from the user? Because if so, it has to be copied big double space.
Yeah, which what do I do? So that's a great question, sort of learning from the user, right? So typically, this is a great question, maybe kind of a long answer.
Okay.
So typically, when you have a model, you don't necessarily want to update it immediately. You kind of want to let it bake and see, how is it doing over time, right? You don't necessarily, there's a question of, do I even want to retrain it immediately? And sometimes the answer is yes, the recommendation engine, right? So if you wanted to incorporate that data into the model on the phone, you would have, so right now, like you said, you would have to so there's two ways to do it. One is you could copy it and have something else in your Swift code that does sort of retraining of the model on the device. What is probably, which takes a lot of space, probably what I think you want to do is, if you can, then here's the privacy issue, is you'd send it back to the cloud, right? And you'd store it, then you would retrain it, and then you'd ship a new model to your phone. So, does that make sense?
Sort of, yeah.
Yeah, but it's a great question because it's very hard. This is what I mean about things not being solved. What is the right way to do this? Because people are not, typically models are trained elsewhere because you need so much data to make them really accurate that it makes no sense. You can't put all that data on your phone and train it on the But then when you want to incrementally make it better with the user's data on the phone, right? If you don't want to ship it back, it either needs to be a super lightweight model, or you need to have a copy of it in some separate code that retrains it. But then you get into the question of how do I know if it's any good?
Would you like the anonymity of healthcare information, for instance, the metadata? I mean, is there something kind of like that?
So healthcare data is a mess.
Yeah.
Like, it's a hot mess, right? There's a big, PHI and PII, and so the healthcare data I worked with in the past, there's not, you would think there would be, some solution to this, but what it is when I work with that type of data, the people who own the data will obfuscate it in some way, so they'll take away like social security number, and they'll take away all the identifying information and just replace it with some hash or something, and then send it to you. So there's not really like, here's the solution, particularly.
But that has to be cleaned by somebody.
Yeah, it has to be cleaned by somebody. But that's a great question, and the long and short of it is today I think it would be pretty tricky to architect. Like, you could do it, but I think the first question you want to ask yourself is, do I need to do this? Does it make sense to update my model on the phone with the user's data? And then if the answer is yes, then you need to figure out how to do it. I think now, to my knowledge, But I think it's a great question. This is one of the reasons like we're in this space, right? Because people like are asking these questions, and the answer is
To be determined.
to be determined, right? That's why it's an exciting space to work in, right? So it's a great question. Okay, so this is the thing that I think will resonate with you guys. If you have to go through the App Store review process, right, to submit apps. And so every time you update, so right now, if you were to update nothing about your app except for the model, you have to go through the App Store, right? And that's a big pain. And so that's one of the things that we solve right now with our platform is and that's what I'm going to demo in a few minutes, is if your app stays exactly the same and the only thing that is updated is your model, you can bypass the App Store. Like, you can push your model over there and not have to resubmit to the App Store. This is completely kosher with Apple. We have two of our director of software engineering and director of architecture, and both worked with Apple and been building apps for a long time. We have a lot of contacts because I got the question like, is Apple going to shut you guys down? And the answer is no, we don't. So this is so you won't have to go through a review process every time you update your model. And this gets back to what I was saying sort of before about this, right? Like, this whole process happens in a very different cadence from, say, like a traditional, software development, shipping features. Like, data science has not, building these models has not always worked in that same cadence. So one of the things to do is integrate your data scientists into your Agile or Scrum or however you're building your software. But the other thing is knowing that sort of the tasking and timing is different, and so enabling like app development to continue and model development to continue sort of as it does, and then you can just drop in a new model when you're ready. Okay, so Skafos, our product, which I'm going to demo. So our sort of approach to this is what we like to call rapid prototyping with a walking skeleton. So one thing, data scientists are notorious for like taking a really long time to like perfect their models, right? So I get it, right? Like I come from a scientific background. I get that you want to make it perfect, but it's usually not worth spending 6 extra weeks to get an initial 0.2% accuracy, right? Like, that's just not worth anybody's time. And so what we argue is that the thing to do is get a model in there quickly, right? Any model, right? So you can see how it works in your app, then sort of iterate on it. And then you can be like, oh, I understand how this is working, right? Like, this gives you guys the tools to be like, oh, I get what it means to have an image classifier in my app. Oh, I can swap it out for another model. Okay, now I can build the app I want, and I can say, okay, data scientist, this is what I need to classify, like, here's how it works, right? And so it's just going to that walking skeleton really quickly. And as it says on the slide, it's counterintuitive to many data scientists. Like, it was a little bit of an internal battle for me at first, but now I really like it because I can,
Not doing peer review.
You're not doing a peer review. Well, there's also the other thing too. in data science, like the cost of an error, right? Like if you're trying to build a model to detect cancer and you have like a false negative, that's really extremely bad. And so you need to optimize your model against that, right? Like if I accidentally say like you're a cat, maybe it's insulting, but like that's gonna happen, right? Like so
That's our mistake, right?
yeah. So you have to like, but you know, that's a separate talk. Okay. So this is what I'm gonna demo today. And we can ask a lot of questions. So Luke McFarland, our director of product, who's great, he knows from Starbucks actually. He likes to spend a lot of time, this is his idea, he likes to spend a lot of time outside with his kids in the summer. He's like, I really don't want to get poison ivy. So can I build an app where I can take a picture of something and it will tell me is it poison ivy or not, right? And this is a great example of why you want to have it on your phone, right? Like what if you're out in the woods and you have no
Wi-Fi.
No Wi-Fi, your LTE, no signal, and you have your phone, in airplane mode because you want to sort of gather a picture of it with your kids. And so this is an example of one time you don't have it on the phone. So he wanted to build a model, a simple, it's not perfect, right, but a model that classifies 5 different types of plants. So this is the functional architecture of what it looks like. And what I'm going to show you is I have an image classification app, which I'm going to put on my phone, which classifies cats and dogs, right? I'm going to take a picture, I want to see is it a cat or is it a dog, and I'm going to swap it out with this poison ivy model, and then the phone is going to update, and I'm going to take a picture, and it's going to be like, oh, this is poison ivy or not poison ivy or sumac or whatever it is. And so the way that this works, right, is there's like this whole process right here, inputting and cleaning the data, building the model, converting to core ML. Like this can happen wherever you want it to happen. It can happen on your laptop. It can happen in Google Colab. It can happen on Amazon. And then you use Skafos to deliver it into the app. And then there's also, the pod install that you would do to install the CocoaHeads and build. We have some template apps, which is what I use, not being an app developer. The first time I did this, I was like, clone the app, I was like, pod install. I was like, God, I have an app on my phone. And like, we wrote it for you. That's what so you have this framework. So let's do that. All right, and that's end of my slides. So let's do that. We're going to see if this works. All right, I'm going to, first, I'm going to open my workspace. So I've already built this.
Do you mind Command Plus a couple of times?
I would not mind at all.
Thank you.
And we can dig into this code as much as you guys want to. It's also available on our GitHub. So this is our the Skafos. This is all publicly available repositories, and I think we have 5 different example apps. So we're doing an activity classification app, object detection, a recommendation engine. I don't know if we have it yet, we have an app for that, and then image classifier. So that's the one I'm doing. Okay. So now I'm going to go to, so this is our platform, Skafos. I'm trying to get to the log. Let me log out and log back in so you guys can see. Okay. This is how I would log in. Okay, so these are my projects, and this is my image classifier that is tied to this code. So I'm now going to try and mirror my phone. Oh, it's already there. Okay, those are my children.
Oh,
Okay, so what I'm going to do is I'm going to build this app and put it on my phone. Oh, that's because I need to select my phone. So here's my image classifier. Alright. Alright, now that's opening. So this is just our example, right? So it's not anything fantastic. Alright, so we're gonna use a camera. We're gonna take a picture and see if you're a cat or a dog.
Oh, you have to get access to it. Oh, you're a cat.
Well, we'll see. There's a lot of like background.
Uh-oh. Sam, wait a minute.
He looks so weird.
Oh, see, he's showing up as a cat.
Oh!
Here, come here, buddy. Come here. So there are a couple things to note about this. Yeah. It's like that works. So I don't even have his head. See, now I see that. There we go.
There you go.
Yeah.
100%.
100%.
Good job. Hey, good point.
See, normally I don't have like a gut, so normally that's why I bring these guys, right? Because because I'm a former physicist, sorry. This one is named Heisenberg, and this one is named Schrödinger.
Oh, yeah.
Yeah. So here we go.
I thought you were going to call him Gus Frank or something.
And so this guy's a cat, right? So clearly, right, like, cat, you're making too much of my hand in the way. Yeah, I should have been a dog because there's too much of my hand. But like, this here, we can choose from my photo library, right? So, here's my car. My car's in the shop. Because I can't turn
It's almost a dog.
Yeah, it's almost a dog, right? So it basically, do you understand why that happens, right? The model doesn't know anything about anything else. It only knows that cats and dogs exist, and so everything is either a cat or a dog.
Do you ever imagine a Silicon Valley?
Oh, hot dog, yeah.
And so you fed the model pictures of plush cats and dogs as well?
So no, we have not. So I didn't actually look at all of the pictures. So I think this is trained, I want to say on like 25,000 pictures, so maybe like half and half of cats and dogs. So it is honestly, like, it's an okay model, but it's not amazing, right? And the point of that is like, so we can give you guys a model. Here's a model, it is built, so you can see how machine, right? This is, I showed you how machine learning works in an app, right? It's like super basic, but the idea is like, oh, here's, I can get the wheels turning, right? Like, you can see how this works, yeah. So the model, I don't think it may have, there may have been some plush cats and dogs in there, but to be honest, I don't know, since I didn't look at all the photos.
What about the poisonous plants?
So the poisonous plants, there's less of this, we'll get to those in a second.
Okay.
So this particular model is showing cats and dogs. We have not done anything with poisonous plants yet. That one was even smaller. That one I think was maybe like 60 different images. And so these were built also, I'm going to take a slight detour. Patrick, you have a question?
Yeah, it's basically this, like, how many images would you typically try to collect if you want like a really good model?
Yeah.
And also, do you need like, here's poison ivy, like here's 2 other plants that are not poison ivy?
Yes.
You do need that.
So what you need is, you need a couple of things. This is great because it leads well to my segue. So the number of images you need, it depends, right? Obviously more is better. Have you guys heard of something called transfer learning? So what transfer learning is when you have a neural network, right? It decomposes the images like there's different layers, right? You have layers that identify color and other things, right? And so the way transfer learning works is you can build a network on images that have nothing to do with what you actually like. So I can build a neural network for cats and dogs that can build on images of all sorts of things. But then you can basically pull off the top layer, right? Because red is red, right? It doesn't matter if it's a picture of a shirt or a dog or a book or whatever, right? But so you can transfer all of this like intense compute, the time you spent, you can sort of transfer it over, like you basically pull off the top layer of the network and then you can use it to build something else. So that's how we use a framework called Turing Create to build these, and that's how Turing Create works, is it uses something called transfer learning. So I call one line of code and it does all the work for me under the covers. And Apple bought Turing Create. Yeah, so it's pretty, so the question of how many images to use before transfer learning,
A lot.
astronomical, right? And so it's always better, in some sense more is always better, but one of the nice things is you can start with like 10 or 20 or 30 in each category and then see how you do. And then that's why it might say that, you're a cat because it's not great or there was too much background, right?
Or one lens in the way.
Yeah, or whatever, right? Your question about do I need poison ivy and not poison ivy, right? The poison ivy model has 5 different categories, and so the way it was trained is this is poison ivy, this is a picture of poison sumac, this is a picture of like whatever else, the different looking like whatever, right? So that's called like a multi-class. So this is just binomial, right? It's a cat or it's not a cat. And not a cat is a dog in this case, but multi-class is poison ivy, Eastern Atlantic, whatever, look-alike, et cetera, et cetera. So, does that make sense? So you have to have everything labeled. Like it can be labeled as whatever, but the number of labels is the number of categories. And it's actually pretty funny because TensorFlow, which is a machine learning framework, they have some apps, right? So I downloaded one and put it on my phone, and they have this like video classification, but it was trained on so many things, like it can't identify anything correctly. My kids love it, right? Because they're like, you know, you're an apron, like you're a whatever, you know, but it's not that the model is like, it's not that they don't know what they're doing, it's just, it was trained on so many things, and what it happens to look like, it only knows about the labeled things it was given.
Yes, right.
Yeah. Okay, so now let's swap out this dog cat model for poison ivy. So I'm gonna go to Skafos, and I'm gonna scroll down, and so these are my assets, right? And so the asset is, in this case, it's a zip core ML model, but an asset could be multiple things. Like if you had a recommendation engine, or if you had like a text classifier in particular, your model would be the model plus like something else, right? So I'm gonna select the zip file, and I'm going to say, this is the model that's gonna identify poison ivy, and I'm going to call it image classifier. So the reason, so I'm gonna call your attention to a couple things. So the reason I'm calling it image classifier is because in this code, yeah, it has to match. So you can call this whatever you want, but in order for Skafos to pick this up, like it has to match.
Can you command plus a little bit more? It's a little bit smaller.
Yes, sorry. Is that better?
But yeah.
Okay. So we have to call it image classifier. This other thing here, so there's Skafos.load. So this is, we have an integration guide. So this tells you how to integrate our framework into an existing app. And it's available, so you can get to it from here, right? If you have an account and you're logged in, you're in a project, you can click on the integration guide, but it's also available in our online documentation. But here you need to have a tag, and the tagging, I'll explain why that's important in a minute, is you have to get the name correct and also the tag correct. Okay, so we're gonna upload this. I don't know, oh my gosh, this is definitely.
It's, you gotta put Wi-Fi.
Oh, well, I was doing it at the hotel earlier. God, it's taking forever. Okay, so the upload is successful, right? So this is what we just uploaded. So there's a difference here between saving the assets and the publishing of the assets. And the saving is sort of relates to that sort of asynchronous development I was talking about. Your data science team, you can upload all of these assets, and then you get to decide which ones to publish. So now what I'm going to do is I'm going to choose to publish this one. And I'm going to add a new tag, and I'm going to call this latest. And I'm going to get rid of dev latest. So you could have multiple calls here, right? Like depending if I had something in development or production, I might want it to get a different model. This is development because this is not in the App Store, right? Production is App Store. I'm going to uncheck this, and the reason I'm going to uncheck it is because this is what's going to look for. It's going to look for the asset name with the tag latest, and so that's what I'm doing now. And now, I'm going to send a push notification. So I'm going to publish this. So asset successfully published and push notification sent. And it's going to take a minute, so you can see in the log, right, it got that. And so we have to wait a minute because I think it has to go through like the App Store or whatever. It doesn't go through the App Store, but it has to like send a push.
That's all the class.
So you actually like deliver it to the app immediately.
Yes.
Like via push notification.
Yeah. Yep. And you can also do pull, like, so there it goes. So you can see all the logs, right?
Yes.
So you can do this without, the reason it's plugged in is so you can see my phone and you can see the logs, but this happens over the air, right? Like I don't need to be. So now what I'm going to do is I'm going to go back. So now I'm going to use my camera.
So there's no alert on the app. I mean, you could.
So this happens, there's not an alert on the app. So from a user, I don't even notice, right? So I would obviously notice now because now it's saying Eastern poison ivy. I'm like, whoa, this is like way different, right? Like this is not And then if you, of course, make a major change to the app, then you have to go through the App Store review process again, and then you're going to get a notification. But yeah, that was your push notification, and I actually have here. So you keep doing this, I'm like, oh, click OK. So I'm going to go, and I think I have. Where's my poison ivy? It's right at the top. No, it's looking at me.
There it is.
I'm going to take a picture of this.
These are three.
It's like, this is a laptop.
Exactly.
Take a picture of the big screen.
So it's pretty sure, so it's actually, this is interesting.
Did you switch to your?
Oh, yeah, you can't even see that there, yeah, thank you. I do that a lot. Yeah, so it's pretty sure it's Eastern poison ivy, but only at 43%, 28.2 Western poison ivy. There's 3 other classes, but the way that app is configured, it only shows you the top 2. So what this actually is, I don't know, because I'm taking a picture of a picture, right? And that can impact it too. So what we just did, right, is we had this app built to detect cats and dogs, and we swapped out, or hot swapped this model, so now it detects what types of poison ivy. We can go back to cats and dogs if we want to, and then we use the Skafos framework to push the model to the app, and you would not have to go through the App Store to do this. Do you guys have any questions?
Let me ask, we haven't talked about CAPTCHA and that kind of
Yeah,
training and stuff like that, but I mean, is there anything that you guys have to help?
So you don't have to, like, what particular aspect of the
Well, I mean, that's one way it's training.
yeah.
I'm just thinking.
Oh, like, am I, yeah.
Right.
So I would imagine, so I don't know for sure, but so it's saying, okay, I'm a person, right? Like, I'm not a robot. So you're clicking those things, and those are getting sent somewhere, right? So it's like, okay, this is person, check these things, person, not a robot. So I don't know, but I would imagine they either get stored somewhere and then retrained in the model sort of on the cloud, and then you would eventually push it back to the phone. This gets back to your question, right? Like, what if I want to retrain on the phone, which is this data on the phone? So, do we have anything to help with that right now? No, but I think it's definitely like, we're definitely heading in that direction, thinking about like, when do you want to retrain on the device? Like, our sort of focus has been like, how do we just get the model on the device and make it easy for people to use it?
Right.
But it's a great.
But I'm just thinking of layers, like, am I right or how?
So you're getting into another problem that's really hard with this is how do I know how well my model is doing? Like, I need to send some data back, right? Like, eventually, if you really want to train a robust model, I think it's gonna be a long time before we can actually train the whole thing on the phone because of the amount of data, you're gonna have to send it back. And that's something we're also working on putting in the plumbing in place right now, so we can do. The first thing we'll tackle is if you, the developer, are like, ooh, I'm gonna send a little packet of data with my model, and it's gonna do the inputs on the phone and send it back. So I can get like an accuracy, like, oh, we took pictures of these dogs, right? Are they actually dogs or not, right? And we can pull that back in. But then also the point about how do we retrain on the device, I think we'll be tackling that later. But the pipeline of getting the data back is really important to have a place yet where we can just have everything on device at all times. Like, eventually, you have to go back and retrain.
I'm just curious what you're using for this particular image classification, if it was like TensorFlow or
It's a great question. So it was all Turing Create.
Oh, that's right.
Yeah, and I can show you actually, I think Tyler today, this is like, I haven't even vetted this, this is probably a bad idea, but we just recently, so we previously did, so our platform, as I said, we used to cover sort of like the training, like the whole breadth of the machine learning lifecycle. Now we're focusing on delivery, so we're actually working a bunch of stuff out. So we used to train everything in Jupyter. Have any of you guys use Jupyter? Jupyter notebooks, yeah. So Jupyter, it's well, I'll show you when we click into this. So it's a way, it's sort of like an interactive, it's almost like a REPL, but it's maybe a little more robust than a REPL for doing sort of interactive runtimes. And so we recently moved everything to CocoaHeads. Yeah, so you can actually get to this repo. So this is the actual code. Hopefully it will open. Sometimes GitHub is finicky with notebooks, right? So this is just setting up the environment with CUDA 10. But here's the actual model running itself. So I think it uses, I want to say it uses something called ResNet as like the base for its running, but we use Turing Create just because it makes it so simple. People have different opinions about TensorFlow. It's kind of like gives you the kitchen sink, but you can definitely use it and integrate artifacts in your apps.
And then are there particular things that you do or don't support like IMINs or CNNs or different types of models and things? Do you really support all of
We would support all of that. The thing with those is, so that's the kind of thing you would do in a notebook, or you would do on CocoaHeads, or you could do on your laptop. The only way we wouldn't support it, I think, is if your model, even if your model artifact is too big, right? Like that's on you. Like if your ML model is 300 megabytes, but as long as you can get something into a zipped format, and then Skafos delivers it, unzips it, and as long as in your Swift code you have,
some way to tag?
that's some way to tag
Okay,
it.
so you're using CoreML once it gets down on the right.
Yeah.
I see. I see. Yeah. All right.
Yeah. So once it's on the phone, so anything first of all, you don't have to convert to CoreML. Like I recommend it just because Apple's supporting it and it's easier to interact with your Swift code. But you can take a TensorFlow Lite artifact and integrate it with your Swift code, or you can convert it to CoreML and then drop it in. But literally all you
But
have.
you said there's some decay, can you do that?
There can be. It depends, and that again is not a well-solved problem. I would just imagine because the number of different libraries and dependencies and like which version of NumPy you're using like impact our results. And we actually just to be able to run on Google Colab, it was literally like 2.5 days of us trying to install the right and uninstall the right things and get the right version of CUDA to use the GPU. So but yeah, if you can get it in a kernel, we can support it.
Cool.
The other thing I wanted to just show you guys quickly is the way that my app knows like which model is when you set up the project in Skafos, you have the option, to put in your key ID, your team ID, create a bundle identifier, and then Skafos creates this key right here, which you then put in your app delegate. So you cut and paste it before you build the model. And so that's how Skafos is like, aha, here's my one-to-one matching. Yep, and then I have here, I have the same bundle identifier. I sign up for my team, which is still Medicine Machine LLC. We'll change that too as part of the anything. Yeah, so it's actually like, I think it's really simple. I think the hard part, I think there's two hard parts. One of the hard parts is running the app, which you guys are all really good at. And the other hard part is building the model, like figuring out what to build and training it, and then connecting the two. Obviously I'm very biased, but I think we help to make that a lot easier. So.
Let me ask use cases. I mean, what have you guys, as far as in the wild?
Yeah.
Come up with
So we have, we just put an app in the App Store, I want to say today. It's like a 3D printing app that helps you figure out like 3D printing projects. We have a customer, their name's Edit, and we actually have I think we've released like a joint press release. They have an app in the App Store. Yeah, so they're using it. They're awesome, and they actually use a modeling framework called DLib, which I think was written by the way that it's commented and written. He sounds like a grouchy academic, but it's really good for like the landmark detection on the face. And so we figured out how to integrate that into app code, right? Which is much more of a challenge than CoreML, just because Apple built it.
Are we at Q&A yet?
Yeah, we're doing it. Yeah, this is all I wanted to
So we're going to ask about scalability and price points.
Mhm.
Could you
you speak to that? I mean, is it something like if we're starting out with a user base of 50
Yeah,
to
yeah, yeah, yeah.
500 or something?
Yeah, so now it's free, right?
Yeah.
Like we're eventually, we'll probably be free, like eventually we'll be 30 day free trial. But it's not like, if you don't have a ton, if you're someone who like tinkers around your spare time, I want to say it'll be like $10 a month or something like in that range, right?
Okay.
So it's not, it will scale, right, exactly as you said,
Yeah.
with the number of users and the number of devices that you have connected to the.
Is your website on?
That's a great question. Because we're recently rebranding, everything is kind of like readjusting, which is why, let's see.
Just thinking most conferences, you go to the different swag tables and
Yeah. So let's see, do we have, so now it's, we have sign up free, we have, I guess the pricing is not, on the website, but you see, I but you guys can sign up for free. And what we would really love is, because this is such a new space and we're really looking for feedback, like whether or not you guys use our platform, like I would love to just talk to you about how are you trying to use ML? Like what have you tried? Where are the stumbling blocks? Because we want to make sure we build something that meets a need in this community and that people are going to use. And so if we don't talk to the community, they'll find out what you guys want or what you're struggling with.
This is time right, because I've got a client right now that wants to do some ML within the next 6 months, and as far as how and that kind of stuff right there is going to be very really nice. I mean, they like to do it all themselves, but if you've got something prepackaged.
Yeah, well the thing is you can still do, like the app is completely custom, the model is completely custom, it's just the delivery piece and tying it together, right? That integration piece, which, my opinion about stuff like that is if you don't have to reinvent the wheel, like why
I'm all for
reinvent the wheel?
One question, as you're pushing out new models, is there a way to target like a subset of your users so you can say like, we want to try this model out on this like slice of users and then maybe push it out to everyone else?
Yeah, so that's not in place yet, but that's coming, right? So you'll have the ability. You'll have the ability to do that, to have different groups, so you can be like, it's like A/B testing, right? Like I want to give 5% this new model and see what happens, and then if it bombs, right, you can roll it back, right? Like that's another nice thing is you can go and like,
Just national CocoaHeads, not all CocoaHeads.
Yeah, just national. I know. I can edit that right now. We'll say national.
Oh, nice.
You had a question back there.
Yeah, so when you update your model, it sends out a push notification, and sometimes the pushes don't actually get delivered. Does the framework have any way of like checking if there's a new model, if it happens to miss that push notification?
So there's definitely, I think if it missed the push notification, I think, and I'm saying I think just because it's brand new, but it checks. So first it'll check to see what's on the device, or I think it depends because you can have pull or you can have push, and so depending which mode you're in, it'll either check to see what's on the device, or it will check, I think it will automatically check to see if there's something you can pull down, and if there's nothing you can pull down with the right tag, it will default to whatever's on the device. Because you still, when you're building an app, you still have to include the model, right? You still, when you're building it for the first time, you still have to drag it in to the Swift code, but once you've done that, and once you've put all of the right connectors in place, then you don't have to do that anymore. Then you can either be pulling or pushing. But yeah, I believe it does check to see, I missed something.
So you talked a lot about Swift tonight, but at work we still haven't converted away from Objective-C.
Objective-C.
Can we use Skafos from Objective-C yet?
I think so. I'm pretty sure. Let me look in the, one thing I'll do is text Wes because he will know the answer. But let me see, we're gonna check this.
Because we had a problem at work the other day. We're updating Swift 5 that just came out. We had a feature that we were using found a closed source Swift library that recently dropped support for Objective-C. So we just had to pretty much be like, oh, can't do this anymore.
Yeah, you have to use, let me text, I'm gonna unplug this, let me text Wes and see, because he will be able to tell us. Let me see. He's a great architecture. That's a great question, I don't know the answer.
So this would be on CocoaHeads. You could see it. I mean, if you went to CocoaHeads and put in your live name.
Alright, let's try that. See, I'm learning from you guys, okay? CocoaHeads. You definitely do pod install.
Yeah. And so type in your pod name.
Let's see.
Yeah. And there it is, 3.0.
Well, that doesn't, does CocoaHeads say anything about?
Well, yeah, just give me a
Oh, the
second.
manager
We're
for
talking-
books, no.
Oh.
That's just for books,
Yeah.
okay.
So yeah, click on the actual area. All right.
Stop. Yes, I know we lost my.
Look at our world.
Yeah, yeah. It's so funny. I was doing something with Swift, like when I first, so Wes has been writing out for a long time, and at first I was like, Wes, I installed Xcode, and his response was, let the sadness begin. So, and then the other day I did something and like it didn't behave, and I was like, I hate this. Let's see.
You can learn to navigate it. So I mean, all the examples there are all Swift.
It's all
So
Swift.
I'd say
We asked Wes.
Yeah, the pod that was for the library I was talking about earlier was we installed it through CocoaHeads, so that doesn't really say much about what our house looks like.
well,
We
there's
definitely.
also the Git repo. This is from the pod itself, which you should look at.
Yeah, but like I don't think she wants to spend this time to get into
I mean,
this.
I can't, I just feel like texting Wes will be faster
Yeah.
because so we'll see if he gets back to me. Yeah, what else?
I have a question. I see that this is pretty much all geared towards mobile. Do you see a lot of ML like happening in the browser? Or is there for web apps? Is that a use case that might exist?
So yes, it is absolutely a use case that might exist. It's one we've chosen not to focus on now, but definitely there's something called TensorFlow.js. Are you a web developer also? You can
Oh, yeah. And machine learning.
and machine learning. Okay, so TensorFlow.js. Have you run across TensorFlow.js? And you
I've read TensorFlow as well as looking through Python.
Okay. So that's a way to integrate models into web apps, but yes, 100%. I think there is a market for that. But there, I think sometimes, I think more often than not, the models will be hitting some sort of API.
It's already online, so that makes sense.
But yes, absolutely, 100%.
Also, does Skafos support Apple's other platforms? macOS, watchOS?
It's a Swift framework, by the way. That's what it says in the description.
Yeah.
Wes has texted back already. Let's see what he said. He said both Swift and Objective-C can play together. So we have been playing a little bit with watchOS. So Tyler, who's awesome, he's on our team, he wrote on Medium a 3-part series about building an activity classification app for watchOS. But we ran into we're not quite there yet because there was some, I don't remember the details, but there was something where we thought that the translation from the iOS to watchOS would be more seamless than it was. I can't give you any details, but yes, it's we're working on it.
It's got difference.
Likewise, do you guys support Android too?
Not yet, but that's coming, right? Right now it's sort of we feel like we need to nail this for iOS since we've just made such a pivot, but yes, 100%. I think that's a question we get asked most frequently.
Yeah.
So we know, right, because it's a huge component of the mobile community.
Wow, you guys just had an answer for each
It's possible that when we do rebase to get rid of everything else before we release. I can tell you this definitely happens. I'm sure deep in GitHub there's
Oh, you can private repo.
We have private repos. I'm sure I tend to write, especially if I'm working on a problem for a long time. I'm straight and frustrated. My commit messages get more cheap.
Explicatives and the.
I try not to do that. It's definitely
Well, we appreciate it, man. This is really cool.
Well, I appreciate you guys.
Oh, we have stickers.
Yeah, there's stickers and business cards. Please take all of them.
Cool. There's also more pizza and drinks over here if you'd like it.
Thank you guys all so much for
Thank you.